What's up, engineers? IndyDevDan here. There is zero debate in the tech ecosystem. You and I and almost every builder knows that all code will soon be written by AI coding agents. A natural next question is then, how can we design our code bases to be optimal for our AI coding tools? If our AI coding agents are going to be operating our code bases, we should be designing our code bases to be token efficient. It doesn't matter if you're using Cursor, Zed, Claude Code, Aider, or Windsurf. These tools will all change and evolve. Some will die, some will thrive. What matters is how you architect systems of context that can be easily understood and operated by your AI coding tools. Always keep in mind the big three: context, model, prompt. So in this video, we're going to explore the question, what is the optimal code-based architecture for AI coding and AI agents? Why is this important? It's important because if you manage your context, you manage your results. In the generative AI age, this is the name of the game. If you manage your context, you will manage your results. Let's break down the key questions we're going to answer. What is the optimal code-based architecture for AI coding? What is the optimal code-based architecture for building AI agents? And then lastly, and most importantly, does it matter at all? As AI coding tools progress, as new agentic tools like Claude Code emerge, we have to zoom out and answer the question, does it matter at all? Great engineers always stop to ask if the problem they're trying to solve is worth solving at all. Does it matter what our code-based architecture looks like? If these three questions interest you, stick around and let's start with a popular yet misused code-based architecture. This is the atomic composable architecture. There are many names for all the structures we're going to look at. I'm using generic versions of these names. What does this code-based architecture look like? It looks like this. We have atoms that are composed into molecules that are then composed into organisms. For each one of our architectures, we're going to break down pros and cons. So what are some pros of this? It's very, very reusable, right? The entire architecture is basically reusable pieces. Reuse is off the charts. This is fantastic. This is going to be in contrast to some of the architectures we're going to look at that have really low reuse. There's a very, very clear separation of concerns. As long as you have a brief description for your atoms, molecules, and organisms, it will be very easy for your AI coding tools to understand this architecture. By the way, atoms, molecules, organisms, these can be named other things. This is the atomic design framework popularized by Brad Frost. It was originally adopted for front-end code bases for composing UI components, but it's really been adopted throughout the engineering stack and all types of code bases. And it's because, just like in nature, there are often smaller pieces that create larger pieces, right? You have atoms that make molecules and molecules make organisms. As you'll see in this video, you can also extend this even further with membranes and ecosystems. If you want to go above the organism level, you can really create as many levels of abstraction as you need. Another super important part about this architecture is that it's very easy to test. Let me show you exactly what I mean. In a previous video, we worked on Pocket Pick. This is an MCP server built to help you store and retrieve information quickly. If I run eza tree get ignore on the source directory, you can see a clean atomic structure here. If we just isolate on modules, we have a single layer of abstraction, right? We have one composable layer, modules. And to be super clear, our modules are just our atoms, okay? And then we only have one higher level. We have the server, right, our MCP server, that then consumes our modules, okay? So we just have one level of atomic units inside of our modules. You can divide these up into additional directories if you want, but the key here is that these are all atoms, right? These are all small pieces that make big pieces, okay? And in this case, we only have one big piece. That's our MCP server. I'll link the video where we build this in a single prompt with Claude Code in the description. That video absolutely popped off. What we get here is a clean architecture for writing tests, right? And this is probably the biggest advantage of the atomic architecture. you can build fine-grained functionality and then isolate them in tests, right? So we can quickly just run, UV run PyTest, and we can see all of our functionality validated. 38 tests ran. This is a well-tested, well-oiled, compact code base, thanks to the atomic structure. And thanks to the small pieces, if you're in your AI coding tools, you can quickly come in here, add the context, and just start working. All right, so that's the atomic composable architecture. It's a very simple pattern for AI tools to follow. It also scales well because you can just keep adding atoms, molecules, and organisms. What are the cons? Everything we do as engineers and builders has trade-offs. What are the cons of the atomic structure? This suffers from something I call the new feature modification chain problem. So what does that mean? It's a bunch of words gobbled together. It basically means when you're modifying an organism or you're adding a new organism or a new higher level composition and you want to change something in the lower level, you now need to go back and change everything that's using the lower level atom, right? And this can be really, really annoying as you start building up more and more molecules and organisms. And if you have even higher levels of abstraction, like membranes or ecosystems, this can be really, really annoying to work with, right? Because now I want to make it one change to insert. Now we need to back test everything else, right? Every higher level composition. So, this is the main con, right? In addition to that, it requires discipline to maintain your proper composable chain. An annoying thing for your AI coding tools is that, like I mentioned, if you need to make one change to insert or even one change to, a molecule, you then need to update everything that uses it, right? So every higher level layer must be updated. And that means that your AI coding tools will need to have even more context in its context window, okay? So this is the atomic composable architecture. As you can see here, there are pros and cons to this structure. Let's move on. The layered architecture is the most popular, widely known, widely established pattern, okay? You basically just have arbitrary layers, right? Arbitrary directories, and they are a logical collection of files. So, a typical one might be interface layer, your API endpoints, your data models, your business logic, and then like utilities, right? This is a very kind of typical structure. We can, just quickly open up literally any code base and you can find that, right? If we look at the Postgres code base, you hit source, you can see this architecture everywhere, right? It's just the simplest architecture. It's dynamic. It allows you to scale really well. You can see we have a bunch of folders that contain specific functionality, right? We can see the same thing in the Redis code base. Redis is interesting because it is a relatively flat architecture with a bunch of header and C files. But nonetheless, this is a classic layered architecture. Just to breeze through this one, there's a clear separation of concerns. It's easy to understand the responsibilities and boundaries of every directory. Cons here is basically you have to import across these layers. Your AI coding tools must operate across API, modules, services, utils, right? They have to operate across everything. This is the trade-off that you make when you build and when you use this architecture, right? And it's important to note that this is likely the most popular architecture, right? The most popular architecture is us having to import a bunch of stuff into the context window. So I think this is a really important thing to keep an eye on. Is the layered architecture the best for AI coding tools? I doubt that. So that's the layered architecture. The pros here is that you can really operate quickly and add new functionality, right? If you think about what this architecture means in terms of how businesses operate and how dev shops operate, you really want to be able to add and modify things quickly, right? That's kind of the core here. And usually, there is some type of layered atomic architecture embedded inside of the layered architecture. For instance, your utils is usually the bottom level, right? Your utils are, if we back up here, your atoms, right? That's kind of where it all breaks down though, right? Because after that, you could have imports cutting across all types of modules, right? And it's not clear, looking at a code base, like for instance, if we hop back to the Postgres database and we click source, it's not clear at all who's importing who and what the rules are there, right? This is the layered architecture, super popular. I'm not saying this architecture is bad. It's here for a reason. It allows us to scale and move and build without thinking too much, right? You need a new API, jump to the API layer. You need a new model, jump into the models directory, so on and so forth, right? Again, the biggest con here is that your AI really has to look across every one of these directories, right? Claude Code, Cursor, Agent Mode, you have to look across all of these files. And of course, that's going to chew up tokens. So let's move on to a super exciting architecture. I've talked to several principal AI coding members about the vertical slice architecture. It's come up over and over and over. To give it away, I think the vertical slice architecture is the optimal architecture for AI coding tools and for agentic coding tools. Let me explain why. Let's just take a look at this, okay? You're gonna get it right away. It's very, very simple to understand why this could be optimal for AI coding tools. Everything is a slice, okay? We have a features directory that contains directories which contain all of the functionality for a specific feature inside your product, inside your application. So we have the users feature slice, and it contains API, model, service. We have the images feature, and it contains, API model and FFmpeg. Just to kind of make it clear, you don't need the same file structure, although this will definitely help your AI coding tools if you have, similar API.py across all your features. And then we have the messaging feature at the bottom, right? So you can see here how this can be super, super clean, super concise for AI coding tools, okay? All you do is import this entire directory, you context prime with this single directory, and we're off to the races, right? You can even do a couple features if you're working on two features at once, right? So I hope you can see why this is a very, very interesting Codebase architecture to pay attention to. Pros, things are organized by feature rather than some arbitrary technical layer, okay? And the arbitrary layer is some logical layer, right? It's there for a reason. But by organizing into a feature, it's a lot easier to collect everything you need into a collection of context. A beautiful thing you can do here, this is all one prompt context priming. So when you're setting up your AI coding tools, it's just a single shot to get this working, okay? And I can show this off here very, very quickly. If we open up Cursor and let's go into the single file agents code base. I have this new directory here, Codebase architectures. If we open up a terminal, cd into this Codebase architecture, vertical slice. So, this is what vertical slice looks like. We have our features, and then we have, projects, tasks, users. If we do aider -- no git, and if we just do /add features /users / we just set up all the Codebase context we need, right? This is it, we're done. So, ask, what does this do? And, we're off to the races. Our AI coding assistant is primed. It's good to go, right? We can do the exact same thing if we want to boot up Claude Code. We can cd Codebase architectures, vertical, open up Claude, and then we can do our classic context priming read. And then same thing, right? Features, tasks /star, that means everything. And now you're going to see Claude read just these files, and there it is. We got that nice new parallel subtask read. It read all those in parallel, 4 tools. Love to see that. And now we're good to go. Okay. We saved a crap ton of tokens. We saved a crap ton of time. We have a simple context priming prompt. Of course, we would probably want to throw in the README in there, right? And README like this, but we're good to go here, right? And something important I want to call out is that the tool only matters so much, right? It's about the patterns, it's about the techniques, it's about, not to sound too gimmicky, but it's about principled AI coding, okay? These principles and patterns that we discuss on the channel and inside the Principled AI Coding course, they allow you to operate on any tool, any model, any code base over time. I don't want you to win just today. I want you to win tomorrow and the day after. We can open up another tool, okay? Let's open up agent mode in Cursor, and we're just gonna say read this, okay? /star, fire that off, and look at that. 4 files right there. It's reading all of them. Cursor agent also picking up on the README. There's a model file, there's a service file, there's the app.py file. You can see the read tools, and that's it, right? It's ready to go, okay? We can now operate on this feature. Doesn't matter what tool you're using. It only matters that it has these capabilities, right? We've context primed Cursor, agent mode, Claude Code, and Aider. All of these AI coding tools are now good to go. They're ready for you to build and operate with that specific chunk of context, right? With that vertical slice of context. Okay, so this is why vertical slice architecture is so important. We get one prompt context priming or one/add command. Moving on here with the pros, it minimizes cross-cutting concerns. As the gears are turning in your mind, any engineer that's worked with this code-based architecture, or maybe you're just thinking through the trade-offs of this, the fact that it minimizes cross-cutting concerns is also a massive, massive downside. Okay, so we also have feature-centric, value-centric structure, right? Which is fantastic. You always want to be thinking from the perspective of your users, of your customers, not of your code base, right? A lot of good pros here. We, of course, can't get too high on our own supply. We're software engineers. We have to have balanced takes. What are the cons here? This structure has terrible code duplication. A reason for that is because what you don't want to do is build out the util/shared, right? You don't want that utilities folder where you share functionality. You actually want to not do that. Sharing cross-cutting code here is a massive mistake. It's a blunder. It's an anti-pattern when you're using the vertical slice architecture. Why is that? It's because you want all of the functionality isolated, right? As soon as you start building out that utils, you're going to have it across multiple features. And now all of a sudden your utils files is going to grow larger and larger. And then when you update a util function, you need to update it across multiple features. And now you're losing that vertical slice architecture, right? Literally defeats the point of this architecture. For these reasons, these are all roughly the same thing. They, kind of all talking about the same side effect. Code reuse here is terrible. I would say probably newer and mid-level engineers are going to have a really hard time with this architecture because you will duplicate code. You're going to have that same API code here, and here. You're going to have similar model scaffolding over and over and over. So this is great, but as you can see, once again, trade-offs are everywhere. Vertical slice architecture is something I'm going to be playing with a lot more. This idea of isolating everything in a single context package in a single chunk is very, very, very powerful for AI coding tools. Moving on. Pipeline architecture. So we have to give a shout out to the pipeline architecture. Functional programmers, the true programmers, they love this architecture, right? I don't think this is super powerful or important for AI coding tools, but nonetheless, it's not a bad architecture. So I want to cover this one because it's important for any data engineer, working on data pipelines, any ML ops engineers. This is a very, very common architecture. You have your pipeline, you have shared utilities, and then you have steps, right? And your steps are composed into your pipelines, and then you run your pipelines, right? Anyone fine-tuning, training, or building LLMs from the ground up, they have some type of pipeline-like architecture. So, pros, great for sequential processing. LLMs love types and clear paths, right? They love patterns. So this is a great architecture for communicating. Your steps and your stages will always link together the appropriate types and data structures, and or save them to that third-party database structure. And of course, language models, AI coding tools, they love that. They love the patterns, they love the types. It makes it easy for them to see and understand what they should do, where they should do it. It's easy to play with these steps. You can reorder these very quickly. Parallel processing is a massive pro for pipeline architectures. So cons, not ideal for basically anything else that's not pipeline driven. And I'm just going to kind of breeze through these other ones. The big problem here is that it's nonsensical for most code-based structures. Very few of us, probably less than 10% of engineers are building out any type of pipeline architecture. And then, state management can be challenging. So these are just four. There are many other architectures, but I think these are the four most important, most common structures to hit on for thinking about building architecture for AI systems. Okay, so for AI coding, we looked at the atomic composable, we looked at layered, pipeline, we looked at vertical slice. Okay, these are all great options. I am heavily leaning toward vertical and atomic for building out code bases that are optimized for AI coding. There are, of course, as we mentioned, trade-offs in each one of these architectures. As we turn our attention to AI agents, it is an interesting question, and it's a question that a lot of us are asking more. What about the optimal architecture for building AI agents? 3 code-based structures stand out to me: atomic composable, vertical slice, and single file agents. We covered single file agents on the channel. What I want to do here is briefly walk through why I think these three structures are great if you're thinking about building out AI agents. And it doesn't matter if you want to throw a framework on top of these, if you're using MCP, if you like Anthropic agents or OpenAI agents or Gemini agents, that doesn't matter. This is all just structural. These structures work with every provider, okay? So let me just highlight a couple things here. If we hop into the single file agents code base and look at example agent architecture, let me show you what an agent architecture could look like for the atomic composable architecture. You can see that similar structure. I'm using the names, as defined in the atomic structure. We have atoms, molecules, organisms, and then membranes. So let's start from the top. So the membrane is your main file, right? And so, this is what we'll use to actually kick off this agent. It has a main down here. So, we can pass in args. This is also where, if you wanted to, you would build out, MCP, right? So you could do something like this, MCP agent. And now you have a command line interface and an MCP interface, okay? So the membrane is quite literally, the API layer, okay? It defines all the ways you can interact with the system, right, with your atomic system. And then, moving into the actual, content, we have the organism, right? And the organism here, using our file agent example, is our file agent, right? So the file agent then composes whatever it needs to from the molecules. It would compose the file reader, file writer, and then those files would compose the file tools, right? So you can see how this works top to bottom, right? The membrane is our access layer. The organism is our actual file agent. The molecule is the components that make up the file agent. And then lastly, the atoms are the lowest level units that we can test, we can run on their own. You can see the insert file here. It's just a function, right? It's a single function, isolated, easily testable, easily composable, okay? So this is what an AI agent design could look like inside of the atomic structure. This directory, by the way, is not runnable. Don't try to hop in here and run this. I am exploring the space here. We're just looking at different potential architectures. So that's the atomic structure for AI agents. I think another great option is going to be the vertical slice architecture for the same reasons we mentioned, right? You can imagine you have your features are sliced into agents, okay? So, if we hop back to the vertical slice architecture, instead of, features here for a typical product application, when you're building out agents, you can look at agents as the individual features, right? And this is really fantastic because everything under your agent is all the context you need to get started. We can open up Aider and then also go into vertical, and then we can boot up Aider --no git /add features /blog agent, and you can see that exact same pattern. Our agent is now good to go. There's nothing else we need to do here. It has all the tools it needs to operate the blog agent. It has all the context, it has the manager, every tool, and it has that top level blog agent, okay? So this is why vertical slice is really important. I think it's gonna be great for building AI agents because you can version them very quickly, right? Say I want to create another version of the blog agent, I can just copy this entire thing and update to whatever, blog agent v2, just like below, right? We have file agent v2, and then maybe you want to change the LLM provider, you can do _Gemini, whatever you want to do here, right? So when we're thinking about building agents and architectures for agents, the vertical slice architecture definitely stands out to me. And so the last architecture, single file agents, this is something that we've explored in a previous video. I also think this is a massive contender. If we scroll down here, in the single file agents code base, you can see that exactly, right? We have tons of single file agents. If we click into one of these, where's the latest one? There it is, file editor, Sani 3.7. If we click into this, we have everything in a single file, right? 700 lines. In other code bases, a 700 line file is an anti-pattern, okay? But in this structure, right, in the single file agents code base architecture, this is just a completely self-contained one file context agent. You can imagine the pros of this, right? It's as simple as this, right? You hop up to the top directory, you file reference, and then you open up Claude, you say, read this, right? And you don't even have to do this, right? You can just start prompting, right? Open up Claude, and you just, you start prompting, change the blah, blah to the blee, blee, okay? But whatever you want to do here. This is an important architecture for building agents. I'm going to keep leaning on single file agents. The fact that you have one file to allow your AI coding assistant to quickly update your agent, I think is a massive win. And just to explicitly mention it, these are the two big themes we're focused on the channel: AI coding, agentic coding, and of course, AI agents. So, here are optimal architectures you can use for building AI agents. If you haven't checked out the single file agents code base, definitely check it out. Link's going to be in the description for you. It's all about understanding agent architecture. It's all about understanding code bases to do and to build with our new generative AI technology, AI coding tools, and AI agents. So full circle, does this matter at all? Right? Cool. We looked at a bunch of architectures. We can see the advantage of them. Does it really matter? I have kind of two answers here. Right now, in the short and medium term, yes. I think absolutely good code-based architecture means easier context management for us and our AI tools. Later, and the more time that goes on, I think you can more easily argue that as LLMs and GenAI evolves, the code-based structure that you're working with matters a lot less. But, I think you can see here from just these few simple examples on, small and, really full-on code bases, context management matters. If you manage your context, you manage your results. So, precise context management still matters. AI needs clear pathways, right? LLMs, to be specific, our LLMs, our AI coding tools, they need clear pathways to, not just one file, but collections of files, right? Collections of information. We all know, Claude Code, Cline, a lot of these tools, they chew up tokens, and they chew them up just looking for stuff, right? They're not even doing work. They're not even creating value. And it's the poor organization of our code base, right? Not to just harp on it, but the layered architecture really forces our AI coding tools to just read everything, right? Look through all of it. We know we're looking for an API file somewhere. Let's look through one of these 20 files in our API, right? This is where the atomic structure and most notably the vertical slice structure, the vertical slice architecture really stand out. If you can build this code base structure, you will save a ton of tokens, right? And I think you can see why. That's important. When you organize your code base, you make it easy to save time, tokens, and that means money, right? Well-structured code is cost effective, okay? The balance is really key here. So, most of us are still operating, we're building for human readability. It's time to flip that trend, okay? I am flipping that trend. I want you to join me. I want you to get ahead of the curve. AI will be writing most code moving forward, right? Our AI tools, AI coding assistants, agentic coding tools, they'll be writing most of the code. That means we need to start thinking about our code bases from their perspective. How can we best organize things to be simple to both manage context, but also just to hand off the entire process to our AI tooling, right? This is why AI readability is now greater than or equal to human readability. The goal here is to help both engineers and your AI tools to navigate your code bases efficiently and effectively. I have an announcement for all Principled AI Coding members. I'm going to be releasing a State of AI Coding essay at the end of March. This is going to help you understand the current landscape of AI coding and agentic coding. I'm going to share the tools I'm adding. I'm going to share the tools I'm removing. We're going to discuss what's next. We're going to break down the tier list of where you should be as an engineer and where you can be as an engineer. I'm going to break it all down into one comprehensive document, one comprehensive essay. This will give you an inside perspective on AI coding, agentic coding, and the big trends I'm seeing that I'm preparing for, that I'm betting on with my money and time. I'm going to share all those ideas and more with you in the State of AI Coding for Q1 2025. That's going to be exclusive for Principled AI Coding members that have completed the course. If you're not already a part of Principled AI Coding, I highly recommend you check out this course, especially if you made it this far into the video. You clearly have some chops. You're clearly an engineer that's interested in great design, in great architecture. Do not miss out on the AI coding train. We're quickly moving from AI coding to agentic coding, which is the next level of AI coding. This is the new standard. If you haven't caught on to this already, this is the way code is being written. Most code, as we discussed, will be written by AI coding tools. 2025 is the last year to get on this train before you deprecate your career, before you deprecate your engineering abilities. Over 8 lessons, we break down core principles like the big 3, right? Context, model, prompt, that's going to help you win in the generative AI age as an engineer, okay? We go from beginner to intermediate to advanced. We have great reviews from real engineers operating in the space. Hop in here, check this out. Link is going to be in the description for you. For all my existing Principled AI Coding members, stay tuned for the State of AI Coding breakdown coming at the end of March. I'm packing a ton of value into this. It's going to help you make decisions and stay ahead of the generative AI wave. You know where to find me every single Monday. Like, comment, subscribe, and I'll see you in the next one. Stay focused and keep building.